Welcome back to the channel, guys. Today we're going to do another topic in our very last chapter. This one is about box and whisker plots. I don't know if you've heard about these before. I'm hoping maybe in 7th grade they talked about these a little bit, but if they didn't, that's okay. I will be honest, I never learned this when I was in school, all throughout high school, all throughout college. I did not learn this until I actually had to teach it in my very first year in 8th grade math some 15 years ago. And to be truthful with everybody, the very first year I taught it a little bit wrong when it comes to making the graph. I'll show you what I mean here in a little bit. But box and whisker plots, they are a way to show the variability. Those show how kind of bunched up or spread out data is. Shows the variability in a data set. It includes 5 numbers. Our book calls it a 5-number summary. I've never really seen that term before. Our old book didn't use that term, but here are the 5 parts of a box and whisker, of a box and whisker plot. You've got the low extreme. That's the lowest number in the list. That one's going to be easy to find. You've got the lower quartile. Some people call it Q1. Our book might also call it the first quartile. The first quartile or Q1, or our old book called it the low quartile. The median, we know what a median is. We've done the median for a long, long time. We also have an upper quartile, which some people will call Q3. Our book will call it the third quartile. And then we have an upper extreme, which is the biggest number in the list. And so eventually a box and whisker plot will look something like this. You'll have a number line. The number line will be spaced out and numbered evenly, like, maybe that's counting by 5s or 10s or 15s or 20s or whatever they're counting by. And then they will have it's usually above, but it can also be below. A box and whisker plot will look something like this, where you have kind of the box part in the middle, right? There's your box part right here. And then you have obviously the 2 whiskers over here on this side and over here on this side. Every once in a while you won't have a whisker if sometimes you get the low extreme and the low quartile is the same number. It is possible not to have a whisker at all, something like that. Or every once in a while, if you ever see one like this with a little star, that means there was an outlier. But we're not going to get that detailed and talk about outliers today. Maybe next year you will learn about that a little bit more. So anyway, those are the basics, and let's move on to the next part. Okay, how do you make a box and whisker plot, right? So I just went online earlier, and just today I looked at the number of COVID-19 cases in our county and then the counties surrounding our county, all the counties that are bordering our county. And here they are, 1, 2, 3, 4, 5, 6, 7. There are 7 counties, ours and the 6 that our county borders. And so I wanted it to make a box and whisker plot of this data. Okay, how do you do this? How do you create a box and whisker plot? Well, first of all, you need to put the numbers in order because we need to do the median. So step 1, we've got to find the median, right? The median, we've done a lot throughout middle school. Put the numbers in order from least to greatest. 62, 64, 219. Okay, so I've got the numbers in order, and then you find the median. The median is the number in the middle. So I've got this and this, there and there, there and there. Okay, I like to kind of highlight it with a circle. You don't have to highlight it, but I kind of like to highlight it like this. Sometimes I even label it M for median. So there's our median, right? Now, what does the median do? When it comes to a box and whisker, the median will split your list. Think about like in our gym, how we can roll down the wall and split our gym into the girls' side PE and the boys' side PE. I like to think of the median as your divider, because look what you get. You get this group of, I like to call them the big boys, right? The big numbers, the numbers that are bigger than the median. And we also get this other side, which should have the same amount of numbers, right? And then we have the little guys, right? Now, the median is your divider, right? The median is not a part of either list. And so we have 3 numbers in the little guys. We have 3 numbers in the big boy side. It should always be equal. If for some reason you do this on your own and you have like 3 numbers over here and 4 numbers over here, that's a clue that you have messed up and you need to go back and put the median in the right spot because your median is incorrect. So you should always have the same amount on this side that you have on this side. Okay, so now we have our list divided into the little side and the big side. And now what you do is now we do the, well, now I don't know how to describe it. We find the quartiles, right? What are the quartiles? Quartile 1 and quartile 3? They're just the median of each one of these lists, right? So basically you're just finding the median 3 times. You do the median of the entire list all together, and then that median is done, and then that splits it into the big numbers and the little numbers, and now find the median of the big group. So now I'm not doing the median of the whole list anymore, right? I'm just doing the median of these 3 right here. What's the middle of those 3? The middle of these 3 numbers is obviously right here, right? That's going to be our Q3. That's going to be our upper quartile. And then you also find the median of the little guys. What's the median of these 3 numbers? And the median of these 3 numbers is obviously right here, right? And that is Q1. That's the lower quartile. And so that's how you do a box and whisker, right? We have almost everything we need. In fact, we have 3 of the 5 numbers in our 5-number summary, right? We have the first quartile, this. We have the median. We did that first. We have this. Now we just need the low extreme and the upper extreme. The lower extreme and the upper extreme are easy to find. They are simply the biggest number in the list and the lowest number in the list. All right, so here's like the biggest number in the list, and here's the lowest number in the list. Okay, so we have our 5 numbers. There they are. I've got triangles around the 2 extremes. This is sometimes called the upper extreme, and this is called the lower extreme. We've got boxes around, or rectangles around the quartiles, and I have a circle around the median. So I have my 5 numbers. I like to do the extremes at the end. You can actually do the extremes at the beginning. It really doesn't matter. There's no math to do. You just pick the biggest number and you pick the smallest number. And now we're ready to make it into a graph, into a display. Now, if I'm being perfectly honest with you, this number right here is actually an outlier, and so if I was doing this in a real statistics class, I would probably do the outlier thing, but we don't know anything about outliers yet, so we got to get all the way to 219. You can guess which county that is, right? I probably maybe want to count by 25s. I don't have enough space to count by 10s. So I'm going to count by 25s, which is going to make this kind of an awkward situation because we're going to have a bunch of numbers in a tiny, tiny space. Okay, so I counted by 2 25s, and then here, you know, when at the beginning of my video I told you guys I made a mistake the first year I taught this. The first year I taught this, I actually had the kids put the box and whisker on the number line because, well, I figured why wouldn't you put it on the number line? I'd never done one before. But actually you don't draw the box and whisker on the number line. You do it up above or down below. I have more room down below, so I'm just going to put a dot here. The lower extreme is 3, so I'm going to put a dot where I think 3 is. The low quartile is also 3, so I don't have to put another dot. It's going to be right there. The median is 9, which I'm going to assume is like right there. The upper quartile is 64, which is probably a little bit more than halfway here. And then the upper extreme is 219, way out here, and that is our county, which has all of the coronavirus cases that have been confirmed, at least in our area. So typically you have 5 dots, but we only have 4 because these 2 are the same number. So the middle 3, it's usually the middle 3. We don't have middle 3 though. The low quartile, the 2 quartiles make up the box, the 3 and the 64. The median, you always put a line through the median right there, and then you always make a line, the whisker goes out to the extremes. Okay, so this would be our box and whisker plot for the number of coronavirus cases, COVID-19 cases, in our county and the 6 counties around us. Now, this one looks kind of silly because there is no whisker on the left-hand side, and this whisker is so long because most of the counties are down here, but we've got our county all the way up here with over 200 cases when no one else has more than 64. So this data is very skewed. This data is very skewed to the right. This whisker is so long. This is not very symmetrical. Later on we'll learn this is called skewed right. And what does skewed right actually mean? It means the whisker on the right-hand side is way long. What that really means is most of the data is over here, right? Most of the data was actually on the left. We actually had most of our numbers in this chunk of the graph, right, from 0 to 25. And so that means most of the data is on the left, but you've got this crazy long whisker. This looks like it has a whole bunch of numbers in it, but it really doesn't, right? How many numbers were actually between 50 and 200? There was really just a couple, right, in our list. So that's how you make one. That one's kind of a weird one because we have one county that is way higher than all the others. Let me show you one that's going to be a little bit more normal. I made these numbers up completely. This is just one I just made up in my head. The number of shots that different players attempted in a basketball game, right? So I just said, all right, we've got 10 guys or 10 girls on a basketball team. This is how many shots they attempted in the game. And you can see someone didn't even shoot at all. We got this person that shot the most on the team, and we're going to do the same thing. Now, this one should be a little bit more normal, but just because my numbers, you can tell my numbers aren't that spread apart. This crazy one, our numbers were very spread apart, right? We had a range of 219 minus 3. Our range was 216. On this one, our range is going to be 12. It's going to be much smaller. So, step 1, do the median. In order to do the median, I have to put the numbers in order. 0, 1, 2, 3, 5 is in here twice. No, I messed up already. There's a 4 in there. I always mess up. Trying to go too fast. There's a 4, then a 5, then a 5, then an 8, then a 10, then a 12. Okay, do I have all 10 numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, I double-checked. I've got all 10 numbers written down. I need to find the median. Okay, so I like to put a little dot. I don't like actually crossing out the numbers because when you cross out the numbers then you can't see them. Okay, so I'm stuck here. I have 4 dots on the left. I have 4 dots on the right. I have 2 numbers in the middle. You remember what happens? What happens when you try to do the median but you have 2 numbers in the middle? You add them up and divide by 2. So 4 plus 5 is 9. 9 divided by 2 is 4.5, right? Our median is actually a number that wasn't even in the list. 4.5 is our median. So what does our median actually do? Our median is like our divider, right? We've got these big boys, right? We've got the big guys over here. On this one side of our divider, we've got the little ones over there on that side of the divider. And now I'm just going to find the median of each of these, right? What's the median of the big boys? So I'm going to look at the big guys here. We've got 5 and 12, 5 and 10. All right, so the middle of these numbers is right here. This is called the third quartile, or some people call that Q3. It's actually backwards. That looks like third quarter, like we're talking about our grades or something. Q3. What's the middle of our little guys? Boom, boom. It's the 2, isn't it? It's right here. What's the median right there? This is quartile 1. Okay, and then we also need to take off our extremes. The extremes are the numbers at the end, right? And it doesn't matter. Like you saw me put boxes around some. You saw me put triangles. You saw me put diamonds. You can kind of do whatever you want. It's called the upper extreme. This is called the lower extreme, right? Okay, so now this one should look a lot more normal. Look, I only need to go from 0 to 12. So I could definitely make this count by ones, right? 3, 4, 5, 6, 7, so on and so forth, all the way until I filled up my number line. And now I'm just going to put my dots on there, my 5-number summary. The first dot I have is 0. I'm actually going to do this one above. The other one I did below. It's not a big deal. The first quartile, the low quartile, is at 2. 4.5 is the median. Now 4.5 is obviously halfway, kind of right here where it's smudged, right there. The upper quartile, quartile 3, the third quartile is 8. And then our upper extreme is 12. That was the highest, the person who shot the most on the basketball team. So this is how it typically looks. Usually I have 5 dots. The last one's just kind of weird. You draw a rectangle around the 3 in the middle. The 3 in the middle make the box. This is the box part of the box and whisker. You've always got this little whisker on the left. Well, I say always. Usually you have the whisker on the right. You make this little line that goes right through the median right there. And there you have it. I would actually put a title on this. I would put a title like number of shots attempted, right? And I'm going to put B-ball game. There you go. And so we did it. And you're happy. You're like, oh, man, that looks kind of cool. And I'm done with it, so I'm feeling pretty good about myself. But then you're like, well, wait a second. What was the whole point of that? Just to draw kind of a pretty picture? Like, what's the whole point? What does this actually tell me? How do I interpret this? How do I use this, right? I'd never done this whenever I was in school. So the first time I learned it, I'm like, what's the whole point of these things, guys, right? Well, like I said at the beginning of the video, these can show you a lot about how spread out your numbers are, the variability of your numbers. What is the whole point of the box and whisker? Let me show you. And actually, let me erase these up here in case I need to put some notes up there. What's the whole point of these, right? Why would I even want to do these? These are great. They can tell you the range, right? Can you find the range very easily? Sure you can. It's always this number minus this number, 12 minus 0. I can do the range in about 5 seconds, right? So I could say the players on the basketball team took between 0 and 12 shots, right? But where this is really powerful is each whisker from here to here represents 25% of the data. And so does this one. Even though this whisker is longer, this whisker right here still just represents 25% of the data. So what I could say is, I could say 25% of the people on the basketball team took between 0 and 2 shots in this game. But 25% of the team also took between 8 and 12 shots. So even though this is longer, it still only represents 25%. And then since that's 25 and that's 25, the box part represents 50, right? If we're being perfectly honest, this part of the box is 25. And then this other part of the box is another 25 over here, right? And so there's where you can get your 100%. So I could say, half of the players, 50% of the team shot between 2 and 8 times, right? I could say the top 25% shot between 8 and 12 shots. And then the people that didn't shoot very much, the lowest 25% shot between 0 and 2 times. And that's what can make a box and whisker very helpful and very powerful. You can describe kind of some characteristics about your data set without actually looking at the numbers, right? The numbers are gone. You can't even see them up there, but I can still tell the percentages by using the box and whisker. Okay, I'm going to keep moving on. Just got a couple more. Looks like I have 2 left. So when you get some questions that ask you to interpret a box and whisker, it kind of got scratched off there, but I can put them back in there. I just made this one up. I don't even have a title on it for you, but that's okay. If you get a box and whisker and it asks you for the range, could you find the range? Of course you could, right? Right here, 40 minus, there's the low extreme, 10. So in this case, I would say 40 minus 10. That equals 30. So I could say the range of this data is 30, right? I could say 25% of my data is in between here and here. So I could say 25% was between 10 and 15, whatever this is, right? Maybe this is how many, I don't even want to make it up. I'm just going to say 25% of our data was in between 10 and 15. And then this says 50%, kind of got smeared out of there. 50%, remember the box is always 50%. So I could say here, my box part, this is 50%. 50% of our data was between, the middle 50% even, was between 15 and 30, right? And then the upper 25%, these are usually like your high performers. Like if this was the number of push-ups you could do in a minute, right? The upper 25% was between 30 and 40. You can see the person who did the most here would have been 40. Oh, here's a new one. I haven't said this all video yet. IQR, if you ever see that, that means interquartile range. Interquartile range. Remember the quartiles were this, right? Quartile 1 and quartile 3. So interquartile range is just subtracting these 2 quartiles. It's not the range of the whole thing. It's not the extreme minus this extreme. Interquartile range is just the right side of the box minus the left side of the box. It's just how spread apart, is the box, the range of the box. So in this case, we have 30 right there is our third quartile. We have 15 right here is our first quartile. And our interquartile range is 15. So I bet you're going to get some questions like that today on the on the assignment or in the question set. It's called interquartile range. It's not the range of everything, right? It's not 40 minus 10. It's the range of the box part of your box and whisker. The third quartile minus the first quartile. And then is this skewed? This says skew. Skewed means, is this symmetrical? Is one of the whiskers longer than the other? Right? Do you see how this whisker on the right-hand side is a little bit longer than this one? So I would say this is skewed to the right a little bit. This is skewed to the right. When it's skewed to the right, it means that most of the numbers are on the left. Right? It kind of seems backwards, right? Since it's skewed to the right, since this whisker is really long, that means actually most of the numbers are on the left. So I would say most numbers are on the left. And I'm running out of room here. Erase that. So whenever this whisker is longer than the other one, it's skewed to that direction, which means most data was on the other side. It's kind of like, you know how if you're walking on a balance beam or a teeter-totter, if you start to lean in one direction, you reach your hand out and you try to like balance yourself on the other side. That's kind of how I use this as an example. Like this whisker is really, really long because almost all the weight or a lot more of the weight is over here on the left. So this little arm is having